Welcome everybody. This is the A-level statistics networking event for effective strategies for exam preparation. So this is the first, I believe, training event that we've had for A-level statistics. And one of the questions that usually gets asked around this time is, what is it that we actually have to write down in an exam in order for the students to get the marks? And it's one of those things that it's not always very clear what actually needs to be written down, and that's the reason why I wanted to run this training event. So just as a little introduction, if you don't know who I am already, my name is Dr. Ali Everett. I've got a PhD in pure mathematics. I've been teaching A-level statistics for over 10 years, believe it or not. This qualification has only been running since 2017, but under the old modular system, A-level statistics existed, and I used to teach that as well. When the qualification, this qualification was introduced, Pearson approached me to ask me whether I would mind writing the scheme of work for it for the country and well, for people who are running A-level stats. And so I did. I ran it, I wrote it, and I published it. Well, I say published it. Pearson published it, and I've had a lot of good feedback from it, and I think Pearson have got a lot of good feedback from it. I will talk a bit more about the scheme of work later on in the session. What other things I do? Pearson also employ me as a credible specialist, specifically for A-level statistics, which means that a lot of the practice papers or the shadow papers and the topic tests that you can find on the Maths Emporium, they're all written by me. I'm also an examiner for GCE A-level statistics, specifically paper 3, but I'm not a senior examiner. I'm just a regular bog standard examiner, and as my day job I am also the course leader for A-level statistics at Hereford Sixth Form College. So that's just a little bit about me, and if you didn't know what I looked like before, that's what I look like with a signature tie-dye hoodie. So today, what are my plans? Well, my aims and objectives, we're going to look at 3 things. Okay. One of the things that we need to have a think about when we write down answers for these examinations is we have to actually think about what is it that the exam is assessing us on. Now, in order to do that, we should probably have a chat about what the assessment objectives are for A-level statistics. So I want to go into that, spend a good 10, 15 minutes on explaining what it is that the examination is actually assessing our students. I also want to go through some general strategies for answering questions. So these are kind of questions which they are cross-topic, they have the same kind of format, and I just wanted to make sure that everyone is aware on what the best way of answering these kind of questions are. And then finally, I wanted to go through some very subject-specific strategies, specifically on technology. That's usually something that people find difficult, knowing what to write down for those technology questions. Things like designing experiments and the statistical inquiry cycle, knowing exactly how to write down the answers to get the marks for that. Data interpretation, hypothesis testing, obviously is quite a big part of the course. And also effect size, because if you are new to A-level statistics, then you are very much new to effect size as well, because that doesn't appear anywhere else in the mathematical qualifications. So let me start with the assessment objectives in A-level statistics. Now, those of you that have seen things like the mark schemes, what you'll find is that one of those columns in those mark schemes says AO, and there's usually a little number that is next to each mark over what that AO actually is. Now, AO stands for assessment objective, and they are very, very specific assessment objectives that are run. Now, these are set by Ofqual, and therefore Pearson have to abide by this. And there are 3 assessment objectives: AO1, AO2, and AO3. Now, what you'll see on the slide in front of you is literally lifted from the Ofqual subject conditions and requirements for A-level statistics. So AO1 is to demonstrate knowledge and understanding using appropriate terminology and notation of standard statistical techniques used, either to collect or represent data, to calculate summary statistics and probabilities, and in relation to hypothesis tests and inference. Now, that makes up 55% of all of the marks in every exam setting. Now, when I looked at that, I refer to that as knowledge and understanding. What do the candidates know? What do they understand? Those little facts, those kind of calculations, that all comes under AO1. AO2 is interpret statistical information and results in context and reason statistically to make predictions, construct arguments, make decisions, and draw conclusions. Now that makes up 25% of all of the marks in every exam setting. And that is the interpretation aspect of statistics. Yes, you've got this number is 3, but what does that number actually mean in this particular context? The third assessment objective, AO3, is critically assess the reliability and validity of statistical methodologies and the conclusions drawn through the application of the statistical inquiry cycle. That makes up 20% of all the marks up in every exam setting. And to me, that is what I would refer to as critique. You are critiquing the statistics. You are analysing whether if something is suitable or whether something is not suitable, if something is reliable or not reliable, or whether it's valid or whether it's not valid. Now, when we break it down, you will actually find that it is very different to other mathematical qualifications in the sense that there is a lot more explaining, there is a lot more interpretation involved in these kind of exams. The actual mathematical calculations actually makes up quite a small portion of the marks that are available in A-level statistics exam. Now, I want to break this down to, before I say that, weightings of each assessment. Now, obviously, we can never get bang on 55%, bang on 25%, bang on 20%. That just comes down to the nature of the questions. It does say in that off-call guidance that weightings of the assessment objectives may be plus or minus 2%. That's just to give a little bit of leeway. So it may not be bang on 55%. It might be 56% for AO1. But we do have that little bit of tolerance involved when writing these exam questions. Now, AO1, the knowledge strand. Now, that's actually divided into 3 different strands. And what you'll notice is on the mark scheme, it will say things like AO 1.1, 1.2, and 1.3. Now, 1.1 is demonstrating knowledge and understanding of techniques used to collect and represent data, specifically to collect and represent data. So AO 1.1 is anything to do with data collection, organization, representation. So what we're talking about is things like sampling questions, anything to do with technology, anything that involves calculations from diagrams, that all comes under AO 1.1. AO 1.2 is the same thing, but that is about things like calculating numbers or calculating probabilities. That is what I would refer to as the majority of what we would consider mathematics. The calculation of probabilities, numerical measures, using probability distributions like the normal or the binomial, that all comes under the umbrella of AO 1.2. And finally, AO 1.3 is to do with hypotheses and inference. So anything that is relating to a hypothesis test or a confidence interval. So if you were to just look at the calculation of, for example, a sample mean, by itself, that would be an AO 1.2, unless it is going to be used in the production of a hypothesis test, in which case it makes it a 1.3 mark. Now, there is no restriction over how the 55% is divided over the 1.1, 1.2, and 1.3. All I know is that all of 55% contains all of these 3 strands. It does try to get balanced out over the course of the 3 strands, but all of AO1 comes under 55% of knowledge. Now, AO2, the interpretation, that is just one strand that is consisting of 2 elements. The first one is AO 2.1a. And that is, can you interpret statistical information and results in context? So what I mean by that is relating all the information, all the results that you've got to the context that is given in the question or the task involved. Now, some example questions you might get from that would be things like interpreting the conclusions of a hypothesis test, or, for example, interpreting the A and the B in the equation of the regression line, and or selecting the appropriate probability model from a particular context. Now, AO 2.1b is the same thing, but about making predictions, constructing arguments, making decisions, and drawing conclusions. So what I mean by that is, can you form a statistical judgment using appropriate statistical terminology? Now, example questions like that would be things like, do you know whether to reject H0 or not reject H0 with numerical evidence? Can you determine if there are any outliers in a data set? Again, backed up with numerical evidence. Can you select blocking factors in a particular experiment? So things like that, where you are reasoning statistically, constructing arguments, and making decisions, that comes under AO 2.1b. Now, AO3 is the critique. Again, it's one strand that contains two elements. AO 3.1a is, can you critically assess the reliability and validity of statistical methodologies? And AO 3.1b is the same thing again, but for the conclusions that are drawn through the application of the statistical inquiry cycle. Now, there are some words in there that really do need defining, and thankfully they are defined in the off-roll document. Critically assess, what we mean by that is, can they make a judgment that relates to the strengths and the weaknesses? When we talk about reliability, we're talking about the extent to which an experiment produces the same or compatible results on repeated trials. And the validity is the extent to which procedure does what it is supposed to do, what it is designed to do. Now, example 3.1a questions would be things like, can you decide whether a probability distribution is suitable for a particular context? Or using the assumptions of a hypothesis test and working out, is it suitable for this particular context or scenario? Can you justify the use of that particular method? So yes, you've used a sign test, but can you justify why you've used a sign test? That would come under 3.1a. 3.1b would be something along the lines of, oh, Ali concludes this. Comment on the validity of his conclusion. So there, what you're doing is you are not critiquing the method, but you're critiquing a conclusion that is made as a result. So that comes under a 3.1b. So that is how the assessment, how the exam is all structured in terms of the assessment objectives. And I'm hoping that gives you a little bit more idea of what to expect when it comes to the exam. So 55% is all about knowledge, 25% is all about interpretation, and 20% is all about critique. Okay, now that concludes what the first bit I wanted to do. The second bit is about general strategies for answering questions. Now, there are certain questions that will come up time and time again in exams. I'm not saying it will come up every single time, but they are particular wordings of the question, which I think is definitely worth having a look at. I've broken them down into various different types, as it were. So the first thing, bullet points, okay? The one thing that we are not expecting from any student is a full-blown essay. That's definitely not what we're looking for. And it is stated in many examiners' reports for the last few years now, please use bullet points, each written in clear, specific, and concise sentences. We don't want a full-blown essay. We want very clear, concise answers. Now, it is, I said on the slide there, it's sufficient to use bullet points. Really, we want bullet points. One bullet point per point the candidate is trying to convey. That's the key thing. I would avoid trying to get candidates to write two things in one bullet point, because it's what we're trying to do is trying to get them into that idea of bullet point, 1 point, bullet point, 1 point. It's much easier to read. It's much easier to see where those marks are, and it also helps the candidate structure their answer. Okay, here is an example. I've taken this question. This is question 5C from paper 1 in 2022. Now, we don't need to know what the actual question was. The question just said, give 2 reasons in context why the assumptions that Tom made may not be justified. Now, it doesn't matter what the content is. What I'm trying to get across here is what we are looking to see as a structure of an answer. And my model answer would be something like this. 2 bullet points. Bullet point number 1, not all tickets for each film will be sold if the film is not popular. Turns out that question was about the cinema and films. But the point I'm trying to convey here is, it's the bullet points that we look for. Family groups with multiple children may watch the film, so concession tickets sold may not be independent of each other. Again, 2 bullet points, 2 marks. That is exactly what we are looking for. Just as another example, another type of example could be things like advantages and disadvantages. So it could be something like this. This is a question I've taken again from 2022, but this was paper 3. Highlight 1 advantage and 1 disadvantage of blah, 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 blah. It's the structure of the question. And what we are looking for is, again, bullet points, clearly labeled. So my model answer here would be advantage. It is very easy to compare medians and the interquartile range across the treatment groups and time periods. And then another bullet point for disadvantage, and then we can go. Now, somebody in the chat has just asked, if a student made 3 points but only needs 2, will they get full marks? I will talk about that in my next bit. Okay. So they are the bullet points. Exactly what I was about to say, make n points. Okay, this is one of the big things that comes in. So make n points. There will be questions that often ask candidates to list a set number of points. So I've seen things like make 4 distinct comments. Your answer should include 3 different statements. I've seen as many as 5 in past exams. Now, the rules here are, well, I say the rule, the heavy guidance here is that candidates should only be making the required number of statements and no more. So if it says make 4 distinct comments, then they should only be making 4. Now, I'm not saying that everybody will be penalised if they write down more than 4. That's not what I'm saying at all. I'll give you some examples. Okay. If the candidate lists the required number of points or fewer, then for every correct point that that candidate makes, then they will be awarded 1 mark. Any incorrect points will score 0. If, however, a candidate lists more than the required number of points, if all of the points are correct, or some of the points are correct and some are technically correct but not actually relevant to the question, then the candidate will be awarded 1 mark for correct statement up to a maximum of the allocation for that question. However, it is possible that if there is 1 or more incorrect point listed, then the candidate could be awarded 1 mark per correct point up to a maximum of 1 less than the mark allocation. So it is possible that if it said list 3 comments and it's a 3-mark question and the candidate wrote down 5 points and 2 of them were wrong and 3 of them were correct, the maximum they could actually score there would be 2 out of the 3. I will give a couple of examples. Okay, the reason for this is simply because we are trying to discourage the scattergun approach of writing absolutely everything down, potentially writing down contradictory statements, and it is a part of the assessment that candidates can write down specific, concise answers. So the guidance I'm trying to tell everybody here is, if it says make n points, a candidate should write down n points and try not to go over. So this was an example question. This came up in 2023. It was a bar chart question, and the question was simply make 3 comments on the data in figure 4. So my model solution would be, there you go, 3 correct points. The proportion of males, blah, 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 is higher than that of females. The proportion of people aged 25 to 34, blah, 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 was the highest out of all the age groups. People with high education are more likely to buy order goods than people with lower education. All 3 of those correct. And therefore, that would be awarded 1 mark per correct point. That's 3 marks out of the 3. So E1, E1, E1. The E marks are exclamation marks. Now, here is an alternative answer. Somebody else could write down the same thing, but add in a 4th point. And there's my 4th point. People with high education may have more money, and therefore they're more likely to use the internet to shop. Now, that might still be true. It's got nothing to do with the graph at all. That is an inference that the candidate has actually made. But it isn't necessarily incorrect. And because it's not relevant, but it still might be correct, they would not get penalised for that. They would still get all full marks, E1, E1, E1. However, there is a chance that should that 4th point be something like this, a larger number of students buy from the internet than unemployed people. Well, that isn't necessarily true, because that's not what the bar graph is saying. The bar graph is giving you percentages, not actual numbers. So that final point is technically incorrect. I've written down 3 correct points, but 1 incorrect point. And it is very possible that that candidate would end up only getting a maximum of 2 marks out of the 3. So I'm hoping that makes it a little bit clearer over what we are expecting as examiners and what the students should be expected to write down for the kinds of questions which are make n points. The key thing here is they should only be writing down n points. Okay, context and numerical evidence. This is a big one. Okay, students don't seem to like doing this, but it's so important. So in previous examiners' reports, it does say that all explanations must be given in context. I'm going to give you some examples of answers that are correct, but wouldn't be awarded marks. The sample is random. The population is normally distributed. The second mean is higher than the first mean. The trials must be independent of each other. Events must occur at a constant average rate. There is significant evidence to suggest a difference in medians. As X goes up by 1, Y goes up by 31.5. Then you can see that all of those could technically be correct, but they wouldn't be awarded marks. And that's because there is no context at all in those statements whatsoever. Now, my general guidance to students would be, if you were to look at your solution, could you copy and paste that solution into another question and it still makes sense? Because if you can, you haven't put enough context in. And that's the key thing. You can't write down something which is generic. It's got to be in context. So if the question was about earthquakes, then your answer has to still be about earthquakes. So what I'm going to very, very quickly do is just modify every single statement that you see on the screen there such that it could be awarded marks. So answers that would be awarded marks. So rather than saying the sample is random, it could be the sample of cows is random. There's your context if the question was about cows. The population of the heights of gymnasts is normally distributed. You can see there's the context again. The mean age of Welsh people is higher than that for English people. Again, there's your context. I'm not going to go through all of them. You can see them there. But the key point is that in order to get those kind of marks, the explanations must be in context. And it is very possible that candidates will not be awarded marks for giving generic statements. Also, if you can, arguments should be supported with numerical evidence where appropriate. Now, if the numbers have already been calculated in the question, then candidates are expected to quote them again as supporting evidence. If supporting evidence can be calculated from the numbers that are given, then yeah, I probably should do that as well. Okay, so here's the tips for interpretation questions. Always say what you see. Follow that up with say what that actually means. Back it up with numerical evidence and keep it in context. And they are the four main things on what to remember to do whenever actually when you have to actually put it onto paper, because people are really not too sure on how to structure it. Well, there it is. That's how you structure it. Say what you see, say what it means, back it up with numbers and keep it in context. I'm going to give you an example now. This is one of my favorite questions. This was from 2021, paper 3. It was the final question, and it was about the Northern Ireland multiple deprivation measure. And if someone had told me, 20 years ago that I would be writing a report on the Northern Ireland multiple deprivation measure, then, I wouldn't have believed you. But you can by following the same bullet points. So in this particular question, you're actually given all the numerical evidence there. You're given the medians, you're given the interquartile ranges, you're given some Spearman ranks as well. So this is my model answer. The median, NIMDM, NIMDM, for rural areas is 554, which is higher than that for urban areas at 325.5. That means that on average, rural areas have a greater social deprivation than urban areas. Now, when you actually look at that bullet point, what have I done? I've said what I've seen. The median for rural areas is 554, which is higher than 328. I've said what I've seen. I've said what it means. That means, on average, rural areas have a greater social deprivation than urban areas. You'll notice I've backed it up with numbers. The numbers, they're not just in the question, I've actually put it into my paragraph because it's supporting my argument. And I've kept it in context. The question was about the Northern Ireland Multiple Deprivation Index, or social deprivation. So my answer is about social deprivation. And that is just for the median. And I believe the question was quite a lot bigger. So all I've done is I've just done it again for the IQR and again for the Spearman rank. And you'll see that in both of those bullet points, I've done the same thing. I've said what I've seen. I've said what it means. I've backed it up with numbers and I've kept it in context. And I think that was a 7-mark question overall. But if you follow that structure and if you tell your students, follow that structure, say what you see, say what it means, keep it in context, back it up with numbers, and then talk about every numerical measure that's on there. And that will be the best way of getting those marks in these kinds of questions. Defining variables and subscripts is the next thing I want to talk about. And this is, again, cross-topic. Defining variables. It has been stated in examiners' reports that any answers that are provided, all symbols must be clearly communicated to the examiner. So if a symbol is used to represent a variable, and it's not defined in the question, then it must be defined by the candidate. So if it said, we are looking at the heights of people, but it doesn't say X is the height of people, then the candidate should be writing down, let X be the heights of people. They have to be defined. Okay, so for example, it could just be let X be the time taken to 100 meters. You could say let A1 be the test score in group one. Another one that comes up quite a lot in those hypothesis tests, let D be X minus Y, where X is the recovery time of a patient in the control group and Y is that for the experimental group. So you can see that every single letter there has been clearly defined. Now, using X in a question, in a case when there's only one variable. So if it's just a case of, oh, the question's about the heights of people, and then they use X, if they still don't define the X, they still may not get full marks because the X has not been defined. If it was a bivariate data question where there's a possible X and a Y, or if you're in a situation where there is a dependent variable with lots of different factor levels, like a control group and multiple experimental groups, then again, those letters have to be defined. Simply just assuming that the first one is X and the second one is Y, or using X1 and X2 in the order that it's presented in the question, that is not sufficient. So if you get given three groups, 1, 2, 3, and you refer to them as groups 1, 2, 3, but you don't say that that's what you're doing, then there is a chance you may not get those marks. Okay. Questions just come up. Can this be done by labeling the question? If there is a clear label to the question, so you've got the different groups, group 1, group 2, group 3, and then it's clearly labeled with an arrow, this is group A, this is what I mean by B, this is what I mean by C. That is clearly labeling. And as far as we're concerned, that is fine. But good practice would be to actually write it in words as part of your solution. Okay. This also applies to ANOVA questions. So when there are multiple groups, when you have things like mu1 and mu2, those subscripts, again, it really has to define what those one and those two means. So simply just saying, oh, mu1 equals mu2 equals mu3, but you haven't actually said which one's 1, 2, and 3. You've got to make sure it's clearly defined in the question, okay? Symbols and Greek letters. This is the other thing that's been a bit of a slight issue. This was mentioned as part of the exemplar presentations, which you can find on Maths Emporium. This came up as a result of last year's. Greek letters and symbols must be clearly identifiable. Now, Greek letters. We use a lot of Greek letters in A-level statistics. We use mu, we use eta, we use rho, we use pi. It's important that candidates use the correct symbol. Now, if an examiner and the principal examiners cannot clearly identify the symbol, or they think that that symbol could potentially be one or the other. A lot of examples are eta or mu. We see a lot of squiggles and we look at it and think, is that a mu or is that an eta? And in these cases, we can't give the benefit of the doubt. It's got to be clear, because mu and eta are two different things. So if it is not clearly written on that paper, then the candidate may not get awarded those marks for the hypotheses. So if they write down a symbol and it could potentially be a mu or potentially be an eta, then yes. Someone said same for rho and p. Yes, absolutely the same for rho and p. I will talk about the p issue later because there is a workaround for that one. Okay, so yes, it has already been said in there. Instead of using p, one workaround is to use pi, because then that way you don't have that issue, but I will talk about that in a moment. Okay, someone just mentioned about row S for Spearman's rank. Again, I will talk about that that is on my list of things to talk about. Mathematical symbols is another one. This one came up. I found this one relatively funny until you realise that students didn't get the marks for this. Some candidates like to use circles for decimal points. And in recent years, some of those circles have grown to very large proportions. And so 1.34 now looks like one circle. You can see the problem. That 1.34 now looks like 1034. And that's not right. So I would, if you have any students that do write circles as a decimal point, I would try to discourage from doing that, because it's not very readable. This goes for commonly used symbols. Z and 2, very easy to get mixed up. S and 5 is another one. here's one that usually gets confusing with the greater than symbol and the number 7. That one gets used quite a lot. N and eta is another one that gets used. The capital U, the union symbol, mu, etc. Anything that looks like a U. If it doesn't look like what it's supposed to, then the candidate may not be awarded the full marks for that. So please make sure that your students get the practice at making sure that the symbols are legible. Okay. Now, the final thing I want to talk to you about is mark scheme policies. Now, those of you who've been teaching A-level statistics for a while, you probably may know this. Those of you who are new to it, there are some big differences between the way that the mark scheme is applied in A-level maths compared to A-level statistics. So I wanted to talk to you about this. This is the only time I shall be referring to the A-level maths, because I know a lot of people do transfer into teaching A-level statistics, but they are so used to what a maths mark scheme looks like. The first thing that is different is an N mark in A-level statistics is by default possibly implied. And that means that if the correct answer is obtained with no supporting working, then the method mark may be awarded as well. It doesn't have to be explicitly shown. Every N mark is possibly implied. And the reason for that is because a lot of the calculators can obtain a lot of probabilities or work out p-values or such at the touch of a button. The exceptions to this is if the question asks specifically, for example, to show that the mean is 5.56. If that show that is there, treat that as a command word that we need to see the working. Okay. And the other difference is when you're presented with a choice of answers. So if the student writes down two possible solutions and they are both different answers, what do we do? Well, unlike in maths, all attempts are marked separately, and then the average score of the attempts is taken and rounded down. So if it were a 5-mark question, and then one person writes down 2 solutions to that question, one of them gets 5 marks, but the other one gets 2 marks, then what we have to do is we have to add the 2 together and divide it by 2, which gives you 3.5, and then round down to 3. So that is a change, again, to A-level maths. Right, I think I'm on track for where I wanted to be, which is great. The final section I wanted to do was subject-specific questions. Okay. Now, the first thing I wanted to talk to you about was technology and software, because if you're new to A-level stats, then this will be completely new to you because you don't see this in many of the other qualifications out there. So in the real world, very rarely, if ever, do people analyze data by hand. That's the whole reason why this is in the qualification. Data are always used using software packages. Now, in A-level statistics, we only look at 2 types of software, and that are spreadsheets and databases. Okay, and obviously, if you have access to other statistical software, then by all means, let them have a play. It's great experience. But in terms of the examination, it will only be spreadsheets and databases. Now, the purposes. This is something that is not very well known. So this is something you might want to take on board. Why are there 2 of them? Well, the purpose of a spreadsheet, it organizes your data into a grid of cells, and therefore we can see that a cell is referenced by a letter and a number. Those of you that have used spreadsheets before, you know what that means. If you haven't, then that's what a cell does. And the advantages to using a spreadsheet is that generally they are very intuitive to use. Generally, and you can always organize your data into a way that is really, really nice and easy to read. But the downside is that whenever you open up a spreadsheet, all the data is accessed all at once. And that's not very efficient, especially if it's a very, very large spreadsheet. There is a software limit, how much data that you can store. Now, I know if you're using Microsoft Excel 365, there are quite a lot of cells of data that can be used. Now, it might seem like a lot. So what is that? That is 17 billion cells, 17 billion cells of data that you can use, which seems like a lot at A-level, but as you kind of go through and people who go off to do higher educations, they start collecting their own data, what you'll actually find is that's not actually enough. And I would say I've spoke to a volcanologist, someone who studies volcanoes, who said that they had to use Microsoft Excel 365 to collect their data, and it ran out of memory in 3 seconds because they were collecting so much data that all 17 billion cells were taken up in the space of 3 seconds. So In those situations, a spreadsheet just isn't suitable. A database, however, is slightly different. It organizes the table into tables, which are usually organized by fields and records. And these tables are often themed, and there are often fields of data that are duplicated across the tables. And that's just a way to link the tables together. Now, the advantages of doing it this way is that you don't automatically open up all of those tables whenever you open up a database. All the data are compartmentalized into various different tables, and therefore the only limit to how much data that can be stored is essentially how much storage space you've got on your hard drive. But the disadvantage is they are less user-friendly and they require more knowledge to be able to use effectively. Now, what do the candidates need to know? They need to be aware of general spreadsheet terminology. They need to be able to know how to carry out basic operations on a spreadsheet, and they need to know some knowledge of some basic spreadsheet formulae. So I'm just going to go through each of this is just for spreadsheets for the time being. So the terminology that we are expecting the candidates to know. We are expecting to know the word cell. What is a cell? It's an entry of data in a spreadsheet. It's referenced by a letter and a number. They need to know how to sort the data. The word sort is a key word here. And that's when you order the data either alphabetically or reverse alphabetically or numerically if you're dealing with numbers. Filter is another key word, and that is when only data are displayed given a certain condition. So if you say, I only want to see all of the fields where this number is over 5, that would be a filter, and candidates are expected to know that word. Now, basic operations in a spreadsheet. Those cells with all those data in it can be added, they can be subtracted, multiplied, or divided, and they can be done using those cell references. So if you wanted to add together A3 and A6, you would just use the formula A3 plus A6. You need to know how to do a sort and filter, and all you've got to do is just say those words, sort and filter, and then write down the criteria on which you're sorting by or filtering by. Spreadsheets also lend themselves quite nicely to copy and paste. Okay, and candidates should know about copy and paste. If they've used a computer before, you can copy data from one spreadsheet into another simply just by copying and pasting. And that is especially suitable if you want to merge spreadsheets together. And formulae. Most spreadsheet software, obviously I don't want to limit ourselves to Microsoft Excel. If you use Google Sheets, or if you use Apple Numbers, or if you use any other open source spreadsheet software, most of them have a standard set of formulae which can process the data easily. Now, the absolute basics that candidates need to know about, basic formulae, they need to know about the sum command. And the sum will calculate the sum of the values that they have referenced in their range. So the sum from A1 to A6, that is a standard spreadsheet formula, in which case they can write that down and say that's what the sum is. Equals average is another one, okay, and that calculates the mean. Count is a big one. Count counts all the number of cells that contain a number. Now, what you will find is some questions have that, they give you a table and they say, oh, we've got sum, average, and count. And they are expected to recognize those as spreadsheet terminology. Count, oh, that's the total number of cells that have a number in it. Ah, that's the sample size. You could go for count if, that's a very useful one to go for. That one is when you can specify your own condition. So you can say count all the cells, count how many cells there are that satisfy this particular condition. And then there are other things. There's var.s and then there's stdev.s that can give you the sample variance, give you the standard deviation, the sample standard deviation. If you change those S's to P's, you get the population variance to the population standard deviation. You could do median. Median's a standard command. Quartile, you could ask for the lower quartile, you can ask for the upper quartile. There's loads and loads of things you can look for. In some of the mark schemes, some of them start talking about things like VLOOKUP. Don't worry about those. That's just an alternative way of doing things. The basic formulae that they need to do is up on there. Okay. Now, somebody says in the chat, is it sufficient to write the range? Some questions may give you an example spreadsheet. Is the range given by A1 to A6? Yes, that is absolutely acceptable. In fact, that's what I would write down. So using standard spreadsheet formulae, that's fine. But if a student wrote down, I would use a formula to sum the values from A1 to A6. And if they wrote that all in words, they can still get full marks for that. Okay. So here's an example. This was an example from last year, actually. This was in paper 2 last year. And the question was simply just, how could you use the spreadsheet function to help select appropriate data for this investigation? So my model answer, this is what I wrote down the very first time I saw it. So my model answer, again, we'll go bullet points. First off, the question was, this guy, Michael, I should say, Michael is only interested in people who live in Manchester and Liverpool. So the first thing I want to do is only show the people who live in Manchester and Liverpool. That would be column D, and I only want column D to show Manchester or Liverpool. That is a filter. So I would write down the word filter, column D to equal Manchester or Liverpool. And then what data would I want to use? I'm interested in what their savings account is, which is column G. I would use the data in column G. Now, if you look at the mark scheme, it looks like I actually went a little bit more complicated. All you needed was the word filter for 1 mark and the Manchester and the Liverpool. Okay, and you don't even have to use the column D. You could say just branch. That was fine as well. And using the data in column G, that actually didn't get you the mark at all, because that's not what was required. It was just requiring the filter and the Manchester and the Liverpool part. So I've gone a little bit more detailed there, but it's not technically incorrect, and therefore I would get both marks for that. This one is another one. So this question actually was found on the AS. Now, the AS in A-level statistics was discontinued back in 2020. I would highly advise people to have a look at those past papers, though, because there are still quite a lot of questions in there that are very, very useful to have a look at. And there was this question about coffee and tea drinking nations. And the spreadsheets question in that was, explain how you would use a spreadsheet software to organize your data sets into a format suitable for investigating correlation. So what Deshandra has are 2 spreadsheets, one showing the tea consumption by country and another one showing coffee consumption by country. How do you get it all into one place such that you can compare them easily? So my first gut instinct would be to sort the data into both tables into alphabetical order. That way, all the countries are in the right order. I would then copy and paste both of the tables into one spreadsheet. And then I would clean the data by removing any countries that don't match up. So basically, I have to then go through all the data and make sure that all of the countries line up. That, again, that's called cleaning the data, making sure that you get rid of any bits of data that aren't useful, and line up all the tea and coffee consumption by matching the countries. That's what I would have written down. And if you look at the mark scheme, you get 1 mark for the word sort. You get 1 mark for moving the data. If you see in the notes there, you can have the phrase or copy and paste, etc. And finally, check for differences. Make sure that the countries line up. So although I wrote down 4 bullet points, the 3 things I was trying to say is all there contained in my answer. So again, I would have got 3 marks out of 3 for that. Now, databases. Candidates need to be aware of general database terminology, how to construct queries which select desired data, and how to understand a database structure. I'm going to blitz through this because I'm very aware I've only got 15 minutes left. So first off, terminology for databases. They need to know what a field is. A field is usually represented by columns. It's a property or a trait that's recorded in the database. A record, that's usually the rows. That's just a collection of field values. A table is simply just a collection of records. Now, this is the key word here, query. In order to get any information out of a database, you have to construct a query. Now, what can that query do? Well, a query can select data. It can select only the fields that you want to view. If you can have loads and loads of information in the database, but you only care about, for example, the first name and their date of birth, you can construct a query that will only select those 2 fields. It can sort the data into a particular order, either alphabetically or numerically. It can do a filter as well. It can only display records that satisfy a particular field condition. Now, this one's unique to a database, a group. A query that groups data will return all possible field values with no duplication at all. And join. You've got all of these different tables, but maybe there's some information in that table and some information in that table which line up, and I want to see everything all at once. So what the database can do is it can join the two tables together. But in order to do that, it would need to know how to match up the records. And that's because there will be a field that is in both tables, and you would match it up by using that same field. And it can also combine numerical field values. So standard mathematical operations. So for example, if you said, right, we've got height and weight as your two fields, you could ask the spreadsheet, the database to produce a query that multiplies those two together. And then it will give you a brand new field, which gives you everything there. So a question in the chat: sort and filter functions from spreadsheets comes under a query function in database. Absolutely correct. Sort and filter are in both, but if it's in a database, it has to be within a query. Now, how to understand a database structure? I'm just going to do this by an example. This was an example from 2022, probably my favorite databases question of all time. It gives you the entire structure of the database, giving you absolutely no information that's contained in the database. And it just says, how would you use database software to find the top 10 fastest arrival times for fire incidents during 2018? Now, it's a database. The first thing I need to do for any database is produce a query. What does that query do? Well, first off, I want to make sure I only get the fire incidents. So I look down the list and go, oh, field name, incident group. That will tell me which incident I'm looking for. I want the incident group to be fire. I also only want 2018. So if I look at all the dates, I only want the date of call to be between the 1st of January 2018 and the 31st of December 2018. There's my two filter conditions. But I also want them to be the fastest arrival times. So I'm going to sort by first pump arriving attendance time. That's the thing in the table that tells you how long it took a fire engine to arrive. I want to sort it from lowest to highest. And then I only want the first 10. So I'm going to select the first 10 records. And if you look at the mark scheme, what we're looking for there is we're looking for the word filter. You must see the word filter, and we are looking for any filter condition for your second mark. We also need a sort, and also the fact that we are selecting 10 records. Now you could sort it from highest to lowest. Highest to lowest would be the slowest to the fastest, and select the bottom 10 records. That's fine as well. But you can see that the structure and what you have to actually write down all boils down to the words sort, filter, select, and also the conditions of which you need to satisfy. Now, the main warning with technology questions: if the question is about a spreadsheet, then the answer must be about a spreadsheet. If a candidate writes down an answer which is a database answer for a spreadsheet question, they may not achieve any marks at all. Or they may get some partial credit, but they definitely won't get full marks. Vice versa, if the question is about a database, but a spreadsheet answer is given, then the same rule applies. So candidates have to be aware of which one is which. Now, that's because there are only two technology softwares that we are actually looking at. Spreadsheets and databases. Candidates are expected to know which one is which. So they have to know which one is a spreadsheet answer, which one is a database answer, and if they get it the wrong way round, they may not get full marks. Okay, so very, very quickly then, designing experiments and the statistical inquiry cycle. I don't want to spend too long on this one. These kind of questions often arise in exam papers, not all the time, but they can do, where the candidate's given a scenario and they just have to design the experiment. Okay, now this may include planning, data collection, data organization, data interpretation, and evaluation and review. They are the 5 stages of the statistical inquiry cycle, which is embedded throughout all 3 papers. And they are expected to be able to answer these questions, but using those as a guide. Just a note on stage D. Under stage D is about hypothesis testing, or what kind of inference you might use. Now, even though paper 1 has no hypothesis testing on, the identification and correct selection of a hypothesis test is part of the SEC. And because the SEC is a part of all 3 papers, candidates in paper 1 may be asked to select an appropriate hypothesis test. They won't be asked to carry it out unless it's in paper 2 or paper 3. But if it's in paper 1, they could still be asked to select an appropriate hypothesis test. General strategies here, bullet points again. The question often gives an outline of the structure that candidates are expected to follow, and candidates really should use that as a guide when answering the questions. My advice to candidates is, if you don't know what to do, put yourself in that situation. Put yourself in that situation, and what would you do? And then just write it down. That's what it is, just write it down. And also questions like these often ask you to say what steps you would take to reduce bias. Now, very, very quickly here, I'm saying very quickly quite a lot, candidates often confuse bias with experimental error. And that's things like collecting the data at the same time of day. That will reduce bias. Unfortunately, that's not true at all. Okay, if you collect data at the same time of day, that actually increases the bias because the data are now biased to that time of day. And that's something that candidates also find very difficult to get their head around. So try to make sure that these candidates are aware of which one's bias and which one's experimental error. And if the question asks to reduce the bias, make sure that they are in fact reducing the bias. Okay, this is an example. I'm going to very quickly go through this one. There we go. You see my model answer here. This was just design an experiment. My model answer, it's all structured as bullet points. I've said exactly what I'm going to do. The bullet points in the question say what data should he collect, how he should gather it, how should you use the sample, what hypothesis test should you use, and what would be those hypotheses. I've just answered every single one of those bullet points with my own bullet point. And the mark scheme, you can look at this later, you'll find that my mark scheme, so the mark scheme and my solution are pretty much the same. So that's where you get your 6 marks. But again, bullet points, and make sure you answer the bullet points that are in the question. Right, data interpretation, very, very small one here. Again, bullet points, adhere to the number of points requested in the question. Just one small warning here, common mistakes. Sometimes the question says, make 3 comments. Sometimes it says, make 3 criticisms. Now, if it's comments, then you have to talk about what the data is actually saying. So look at the graph, say to the examiner, what is the graph trying to tell you? If it was criticisms, that's saying what is not good about the graph. Why is the graph not appropriate to display the data? So, for example, CPI is not defined. The numbers are too difficult to read. And what we found in the past is that students who say make 3 comments sometimes give criticisms, and that's not what the examiner is looking for. So comments should be talking about the data in the graph. Criticisms is talking about why the graph isn't that good. Okay, that's data interpretation. Hypothesis testing, okay? Some general things to be noted about what to write in a hypothesis test. I always follow this structure, and I've color-coded it in the same way that I would with students. I tend to go for the colours of the rainbow because everyone seems to know what that is. So the red step, define your variables. I already said what the importance of defining the variables. Orange step, state your hypotheses clearly. The yellow step, declare the test. Is it 1 or 2-tailed? What's the name of the test? What's the significance level? What's the important information that you need to do to carry out this test? The green step, state your test statistic clearly. The blue step, find the p-value or the critical values. Explicitly compare the p-value with the significance level or the test statistic with the critical value. And the final step, the purple step, make a conclusion in context. So just a little note about this. I've already spoken about defining the variables. I've already said about the hypotheses, making sure that all Greek symbols are clear and any letters and subscripts are defined. Now, in terms of the yellow step, although some of that is not actually required for the awarding marks, I would say it's generally a good idea for the candidates to mention these. For the simple reason is that if they write it in their solution, they then don't have to go hunting for it in the question afterwards. It's already there written down. The name of the test, there could be marks awarded for that if the question says to state the name of the test. The sample, the important information could be the sample size, degrees of freedom, distribution being used. They may be awarded M marks. Now, obviously, if they get the correct answer, they would still get those. But if they got the incorrect answer, but at least they said what distribution they were using, there is potential method marks that could be awarded here. Okay, the blue step. Okay, p-values or critical values. Now, you could write them as statements of fact. So, for example, 0.0231 is less than 0.05, or 2.04 is bigger than 1.96. You could write them as statements of facts. Or you could display it on a diagram, which I find easier for critical reasons. This is the way that I would do it. I would always draw the picture. If it was a normal distribution, I would draw a bell curve. If it was a chi-squared, chi-squared. If it was just a sample size, if it was just a scale or a number line, I would just draw a scale or a number line. Okay. There was a question in the chat about the scheme of work. I will talk about the scheme of work. There is an updated version coming soon, and hopefully that will answer any questions that you might have about that. Okay. Now, a note about p-values. Okay, now p-values are a perfectly valid way of getting the marks. Okay, the definition of a p-value is that the probability of observing the test statistic or more extreme if the null hypothesis is true. Now, the p-value and the probability are not necessarily the same thing. This has been corrected in the later version of the scheme of work, which will hopefully be released in a month or so. Now, traditionally, in maths education, before higher education, what candidates would tend to do is they would calculate a probability, and then they would compare it with either the significance level, if it was one-tailed, or half the significance level, if it is two-tailed. But the p-value is actually something different. The p-value is that probability for a one-tailed test. But for a two-tailed test, the probability is actually double that probability. And if you have one of those big graphical calculators, you'll actually notice that the p-value is doubled if you change the test from a one-tailed to a two-tailed test. And that's because the p-value is specifically defined to be double the probability, which means that you could then compare the p-value with the full significance level. Now, in practice, in an exam, it does not matter which one they use. They can either compare the probability with half the significance level, or they can compare the p-value with the full significance level. But if the question specifically says to find the p-value and it is two-tailed, then candidates are expected to double the probability that they are found. Again, all of this is exemplified in the upcoming revised scheme of work. Finally, what should be in the conclusion? I think this is as far as I'm going to be able to get in the hour, I'm afraid, so I do apologize for this. What should be in the conclusion? Obviously, whether to reject or not reject H0. Candidates are expected to use the phrase, do not reject H0. I know a lot of people say accept H0, but that is now very outdated. Okay, modern mark schemes in both A-level stats and maths now use do not reject. They condone accept, but there may be a time in the future where accepting H0 will no longer be accepted. So please encourage your students to use reject or do not reject as part of your conclusion. The conclusion should be in words, okay? You should have the words evidence to suggest because it cannot be a definite statement. There must be a reference to H0 being rejected or a suggestion that H1 might be true in words. It's got to be written in words and in context. The dependent variable, that's the thing that's being measured in the question, that must be mentioned. And any factor levels applicable. So for example, between groups, between types, trees, cars, whatever, that should also be mentioned in there as well. Okay, so I'm not going to go through the example of the hypothesis test. You can have a read of the tests in the actual slides in the documentation. There is also a hypothesis test glossary of what the hypothesis tests are. Now, there was a question about row S for Spearman's rank. The general acceptance these days is that row S is now a perfectly valid way of writing Spearman's rank hypotheses. Now, what you will find is if you Google it, if you look at the literature, opinion is very much divided. Our stance on it is we will accept either it written in words, there is no association, or there is a positive association. We will also accept row S as a valid alternative for Spearman's rank. Okay. In terms of the binomial proportion test, to get around the p issue, we'll turn the p into a pi. That is a good practice. The other good reason is because in a two-sample proportion test, p actually means something else. P is the pooled estimate of the proportion, not the population proportion. So pi should be used in a two-sample proportion test. I would encourage everyone to go for two-sample for pi's in those situations. Again, you can have a look through these slides all the way through for the hypothesis testing. Okay. These four things, these ones have only come up in the sample assessment materials. They haven't actually come up in exams yet, but interpreting effect size with a p-value in combination, you can see the four different cases there. I've written down essentially stock phrases of what students could write down to interpret what's going on. But in terms of the wording, as long as it's all in context, then we should be okay to get those marks. Okay. So apologies. What have we covered? We got there slowly, just a few minutes over. So we've gone through the assessment objectives. We've gone through the general strategies for answering questions, and we got through the subject-specific questions for technology, the designing of the experiments, data interpretation, and we very, very much fleetingly went through hypothesis testing and effect size. Apologies for that. I think I wrote a little bit more than I could actually fit in the hour. But in terms of the resources available, you've got the slides that's in this session. You can find the exam papers and the mark schemes. They are all on the Maths Emporium. You can find all of them. I've also said about the AS exam papers. Even though the AS doesn't exist anyway, you can still have a look at them because they are still good questions. There are 3 sets of practice papers. There are shadow papers as well. There are also now topic tests on sampling, data collection, technology and software, experimental design, and data visualization. They were released, I think, January this year. So they are now all available, and the mark schemes are there as well, together with the assessment objectives. The examiners and reports and the exemplars, I very much strongly get people to read those, because that does give some good information about what examiners are looking for. There are also some student-friendly worked answers, okay? There are the 2024 and the Shadow 2024 are already available, but what I have done is I've given Pearson my copies of 22 and 23 as well, so we've actually got more things going on there. And the scheme of work, I wrote it 7 years ago, 8 years ago, actually. It needs updating. It has been updated. We are still just going through the final things, so that should hopefully be released in the next few weeks or so. It will include links to Desmos activities to help you identify the graphs, but in terms of everything there, the scheme of work should hopefully come out soon, which will hopefully answer quite a lot of the questions that some people have written in the chat. Okay. Subject advice and support, you can contact Vicky Wood. She is the subject advisor for Pearson. You can contact her on teachingmaths@pearson.com. You can contact her on the phone there. And I believe that there is a resources survey that is in the chat as well, which Pearson would like you to fill out if you haven't already done so already. Okay. If you'd like to find out more about professional development, then please click on the links for professional development there. Your feedback really does matter. I really would like to know how you thought of that. If it's anything to do with how much stuff I tried to fit into an hour, I'm fully aware of that. But everything else, please, by all means, provide your feedback. And thank you very much for everyone attending. Apologies, I couldn't get through those last couple of topics, but hopefully that gives you a much, much better idea of what examiners are looking for when it comes to writing the exams. So thank you very much, everyone, and have a safe drive home and a nice evening.